In this video, we will demonstrate group project experiment. This is our group members. First thing first, let us begin with site selection. These are the locations for our lab test. Firstly, outflow meter test. The apparatus required for this test is outflow meter apparatus, stabilizer, stopwatch and water. First, we will conduct the test for rough surface. A 3 kg weight was placed on both sides of the outflow meter. Then, 300 ml of water was filled in the outflow meter. After that, stopcock was pulled, and the time taken for the water to flow, until it reaches the lowest mark, was recorded by using a stopwatch. The test was repeated 2 more times, and the result was recorded. The same step was repeated for a medium and smooth surface. Skid resistance test. The apparatus required for this test is pendulum skid tester, water, ruler, surface thermometer, brush, and measuring tape. First, we will conduct the test for medium surface. The skid resistance tester was set up at the location. Then, the bubble was adjusted to be at the middle, by adjusting the 3 adjusting the leveling screws, at the base of the skid resistance. Next, the pendulum arm was placed at the starting point. The maximum swing indicator was set to 0. Then, the height was adjusted until the friction plate touches the pavement surface. Next, the pendulum arm was released and catched, to prevent backswing of the pendulum arms. Experiment was repeated for wet surface. Minimum of 3 skid resistance value was taken and recorded. The steps was repeated for smooth and rough surfaces. Data was taken and the average value was calculated and recorded. Sand patch method. The apparatus required for this test is sand, measuring cylinder, ruler, spreader disc with surface covered by rubber, brush, and water. Firstly, the site was cleaned by using a brush. Next, 20 ml of sand was measured by using measuring cylinder. Then, the sand was poured onto the pavement surface into a small mound. After that, the sand was evenly spread in a circular motion, by using a circular block with light pressure. Lastly, measurement was taken by using scale ruler. Now, we conduct the experiment for wet surface. Firstly, wet the surface by using water. 20 ml of sand was measured by using cylinder. Then, the sand was poured onto the pavement surface into a small mound. Next, the sand was evenly spread in a circular motion using a circular block with light pressure. Measurement was taken by using scale ruler, and result was recorded. Result and analysis. This is the result that we obtained for outflow meter test. The outflow meter test evaluates the ability of pavement surfaces to drain surface water. The smooth surface recorded the longest average outflow time, 11.55 seconds, indicating poor drainage capability. The medium rough surface showed a shorter average outflow time of 8.75 seconds, suggesting improved water flow. The rough surface recorded the shortest outflow time, 8.65 seconds, demonstrating the best drainage performance. Increased surface roughness provides more channels for water to escape, reducing surface water accumulation. Faster drainage reduces the risk of water film formation and hydroplaning during wet conditions. Next, skid resistance test result analysis. Firstly, we calculated and evaluated the result for dry surface conditions. Skid resistance values increased with increasing surface roughness. The smooth surface recorded the lowest average skid resistance value, 42.00, while the medium rough surface achieved a significantly higher average value of 86.67. The rough surface recorded the highest skid resistance value, 96.67. Higher skid resistance is attributed to improved mechanical interlocking between the pavement surface and the rubber slider. Rough surfaces therefore offer better friction and vehicle control under dry conditions. Next, we measured skid resistance under wet conditions. Surface texture had a more critical influence on skid resistance under wet conditions. The smooth surface recorded a skid resistance value of 0.00, indicating extremely slippery conditions. This occurs due to the formation of a continuous water film that reduces tire pavement contact. The medium rough surface maintained a relatively high skid resistance value of 78.67. While the rough surface recorded the highest wet skid resistance, 85.33. This proves that rougher textures help break the water film, maintaining friction and improving braking performance. This is the skid resistance graph comparison. Next, sand patch test. The sand patch test measures pavement macro texture in terms of average texture depth. The results under dry conditions showed that the smooth surface had a texture depth of 0.113 cm, the medium rough surface had 0.170 cm, and the rough surface had the highest at 0.204 cm. This give an average of average texture depth 0.162 cm for dry surface. However, under wet conditions, the smooth surface showed a texture depth of 0.156 cm, the medium rough surface had 0.193 cm, and the rough surface had 0.170 cm. This give an average of average texture depth 0.173 cm for wet surface. The rough surface consistently showed higher texture depth, indicating better macro texture. Higher texture depth improves both drainage and skid resistance. A clear correlation exists between surface texture depth, outflow time, and skid resistance values. Surfaces with higher macro texture, 1. Drain water faster, 2. Provide higher skid resistance under both dry and wet conditions. The smooth surface consistently showed the poorest performance in all tests, especially under wet conditions. Rough and medium rough surfaces are more suitable for enhancing road safety. Pavement design and maintenance should prioritize adequate surface texture to reduce accident risk. The experimental results align well with established pavement engineering principles regarding macro texture and friction. Based on the experimental results, surface texture significantly affects pavement performance. Rough surfaces showed the highest drainage capacity, skid resistance, and texture depth, followed by medium rough and smooth surfaces. The outflow meter test confirmed that rough textures allow better water flow, reducing water accumulation. The skid resistance test demonstrated that rough surfaces provide higher friction under both dry and wet conditions, improving road safety. The sand patch test further supported these findings, as rough surfaces recorded the highest macro texture depth. Overall, increasing surface roughness enhances drainage efficiency, skid resistance, and surface texture, contributing to safer and more durable road performance, especially in wet conditions.